Ok, bạn nào mà nghe được bằng tiếng Anh thì sẽ nghe bằng tiếng Anh. Thế còn bạn nào mà chọn nghe bằng tiếng Pháp thì nghe bằng tiếng Việt thì là sẽ nghe bằng tiếng Pháp. Ok, bây giờ chú sẽ đóng cửa sổ chat lại nhé. Ok, được rồi. Cảm ơn mọi người đã kiên nhẫn chờ đợi. Thế và bây giờ chú sẽ lại share lại cái video ban nãy. Hy vọng là khi share thì nó không bị ảnh hưởng gì đến cái cái ngôn ngữ. Ok, tốt rồi. Ok, bây giờ chú sẽ bật cái này lên cho nó tự chạy. Thế và sau đó thì chú sẽ dịch ở bên máy bên này bằng dịch ra tiếng Việt. Bạn nào mà thích nghe tiếng Anh thì bạn ấy chọn cứ để nguyên. Còn nếu mà bạn nào mà thích nghe tiếng Việt thì các bạn ấn vào chữ tiếng Pháp, tức là French. Và khi nào chú Gấu cần phải chuyển đổi qua lại giữa hai máy để nói chuyện gì với các bạn thì chú sẽ nhắc các bạn là quay sang bên tiếng Anh. Các bạn lưu ý giúp chú việc đấy nhé. Ok, cảm ơn các con. Hôm nay là buổi đầu tiên nên là chắc chắn là còn có cái chuyện nọ chuyện kia hơi bị chưa được tốt lắm. Thế nhưng mà chúng ta sẽ cố gắng đi qua cái này cùng nhau. Và chú tin là mọi người sẽ rất là thích cái video của cái trạm thiên văn này. Ok, bây giờ chú sẽ play bên tiếng Anh.
My name is Dr. Valerie Rapson, and I am the chief astronomer at the Dudley Observatory at MySci. Now, MySci is a science museum in All right, well, I have 11:10 here, so I think we will get started with our presentation. So welcome, everybody. Glad that you are here joining us today. My name is Dr. Valerie Rapson, and I am the chief astronomer at the Dudley Observatory at MySci. Now, MySci is a science museum in Schenectady, New York. You can find us on the map in the bottom right there. We're just outside of Albany, New York. So if you know where the capital of New York is, we're just right next door to that. And my job here at the observatory is to run and design education programs. So I get to teach people of all ages about all the cool things that are happening with NASA and in the world of astronomy. So today we're going to focus on our moon a little bit. It looks like we have a range of ages and grades here. So some of you might have already learned about the moon in school, and others, maybe you haven't learned all that much about the moon today. But we're going to cover a whole bunch of fun things, and I'm going to ask you lots of questions. So if I ask you a question, feel free to type the answer in the chat box. And also, if you have questions while we go through the presentation, you can put those in the Q&A box, and towards the end, I will save time to answer those questions. So let's get started by talking about our friend, the moon. So you guys probably have gone outside and seen the moon in the sky before. You might know that the Earth orbits all the way, or excuse me, the moon orbits all the way around the Earth. And because the moon is orbiting the Earth, we call it a natural satellite. Now, the word satellite, you might think of like a big piece of machinery that's orbiting around the Earth, you know, those big things that allow us to use our cell phones and watch TV nowadays. But anything that orbits the Earth, whether it's a man-made object or a rock like the moon, that would be called a satellite. And the moon is a natural satellite because nature put it there. Humans didn't put the moon up there. Nature created the moon a long, long time ago. It goes around the Earth counterclockwise. So if you have a clock in your classroom or at your home that's not digital, that actually has the hands moving, you can look at the way that the hands move on a clock, and you can go the opposite direction. So the moon goes counterclockwise around the Earth, and it takes about 27.3 days to do that. So almost a month for the moon to go all the way around planet Earth. Now I want to talk a little bit about size and distance scales, because one of the things that's hard to understand when you look at the moon is just how big is it and just how far away is it. So we're going to start with the sizes of the moon and the Earth. The Earth is about 8,000 miles wide. So from left to right, and I'm going to make a little red dot show up here. If we go from left to right across the Earth, if we did a straight line, it would be 7,917 miles, or approximately 8,000 miles across. The Moon is about 1/4 of the size. It's 2,159 miles wide from side to side. So that means I could fit about 4 moons. If I lined up 4 moons, they would fit across the front of the Earth. So the Moon is about 1/4 the size of Earth. Now, I have a question for you guys. I'd like you to take a guess, or if you know, you can just share the answer. How many moons would fit inside the Earth? We know we could line up 4 moons across the front of the Earth, but based on how big the planet is, how many moons do you think would fit inside? If you want to take a guess, go ahead and put it in the chat box, and I'll pause for a moment and let you guys share your thoughts and your guesses in the chat box. Let me pull it up here. I see lots of great guesses. 32, 4, 6, 24, 4, 8, 3, 32. Yeah, these are all excellent guesses. So based on the sizes of these two objects, it doesn't feel like you would fit a whole lot of moons inside the Earth. So a lot of you are shooting out low numbers like less than 10. I see some guesses here that are in the 30s. The actual answer of how many moons would fit inside the Earth is 49. You could fit 49 moons inside of the Earth. So remember, 4 moons go across the front, but that still means there's a lot of space above and below and inside. So if I filled the whole Earth up with moons, I'd be able to fit 49 moons inside of the Earth. So the Earth is a lot bigger than the moon in outer space. So let's compare the size of our moon with some of the other moons in the solar system. There's 190 moons in the solar system, and our moon is just one of them. Now, I'm not going to be able to show you all 190 moons, but I've lined up a whole bunch of objects here on this slide. Some of them are planets, but most of them are moons, and everything is shown to scale. What that means is I can compare the size of Earth, which you see on the far left, to all of the other objects, and if a circle looks smaller, that's because it actually is smaller compared to the Earth. So Earth is on the left, and we have a couple familiar planets. We also have Venus, slightly smaller than the Earth, Mars, about half the size of the Earth, and then everything else on the right-hand side here, those are all moons. And they're all shown to appropriate size. Our moon turns out to be the 5th largest moon in the solar system. That means there's 4 other moons that are bigger than Earth's moon. The one that holds the record for the biggest moon happens to be Ganymede, this moon right here. Looks an awful lot like our moon, but it's a lot bigger and it orbits around Jupiter. Next in size is Titan. Titan is the largest moon of Saturn. Then we have the planet Mercury. Mercury is not a moon. Mercury is another planet. We have Callisto and Io. Those are 2 other moons of Jupiter. Io is super cool because Io has volcanoes that erupt on it. And then finally, our moon. Our moon is the 5th biggest moon, and there's a whole bunch of other moons shown on the slide here too. So these are moons of Jupiter, Saturn, Uranus, and Neptune, all stretched out over here. So the moon, while it's pretty big in the solar system, it's definitely not the largest moon of all of the moons in the solar system. Now let's talk about distance. How far away is the moon? If you look up cartoons or even real pictures of the moon online, if you get an image like you see on the right-hand side there with the Earth and the moon is always shown really close to Earth. But is the moon actually that close to the Earth? Or is there a lot of empty space between the Earth and the moon? Let's see if we can figure it out. So I'm going to give you a really big number here. Turns out the moon is 238,900 miles away from the Earth. That's really, really far, and that's a really big number. It's kind of hard to think about something that's 238,000 miles away. So I have an easier way to think about it. Let's imagine that I have the Earth and the moon shown here. So at the very bottom of the slide, the Earth and the moon, they're kind of small, but the Earth is on the left and the moon is on the right. So I could ask you guys, well, how many Earths would fit between the Earth and the moon? If I could duplicate the Earth and I could make a whole bunch of Earths and line them up in a straight line, how many Earths would fit between the Earth and the moon? Do you guys want to take a guess on that one? Go ahead and put it in the chat box. If I could line up a whole bunch of planet Earths, how many Earths would fit between the Earth and the moon in real life? Excellent. I see good guesses coming in. I see votes for 12, 30, 2, 2, 30. Let's see, there's a couple more here. 32, 158, 20. Yeah. These are all excellent guesses. So it's kind of tricky to figure it out, right? We've got another vote, 40, good guess. So it's hard to think about because in real life, the moon feels really close. So it seems like the moon would only be a couple of Earths away from us, right? It seems like maybe 2 or 3 Earths would line up in a straight line and we could get to the moon. But in reality, those of you that guessed somewhat larger numbers are actually more correct. We can fit approximately 30 planet Earths between the Earth and the moon. So I've kind of showed it here. I duplicated the picture of the Earth, and there are 30 Earths all the way out to our moon. So the moon is really far away. There's a lot of empty space between the Earth and the moon. So even though it looks big in the sky, and even though it feels really close to us, there's a lot of space between the Earth and the moon. So now you have a decent idea of the sizes and the distances to the moon. Let's talk about gravity. A lot of people have the misconception that there is no gravity on the moon. But anytime you have a big object like a planet or a moon, there's always going to be some gravity. But the bigger the object is, the more gravity it will have. And the smaller the object is, the less gravity it will have. Since the moon is smaller than the Earth, there's going to be less gravity. In fact, you would experience only 1/6 of the gravity that you experience on Earth. So what that means is if you were to step on a scale here on planet Earth, we're going to pretend that for better or worse, everybody weighs 100 pounds. If you stepped on the same scale but you were standing on the moon, you would only weigh about 16 or 17 pounds. If you take your weight and divide by 6, that's how much you would weigh on the moon. So if you want to, for homework maybe, when you go home tonight or maybe after this lesson, you can go find a scale at your house, see how much you weigh, and then divide that number by 6, and that's how much you would weigh on the moon. Now, since your weight would be lower, that means you would feel like you're not as heavy, and it'd be a lot easier to move around. So maybe you've seen pictures of astronauts walking on the moon. They don't really walk, they seem like they hop. So the video on the right-hand side is an actual video of when our astronauts went to the moon in the 1960s and 70s, and they were walking around the moon, but it actually worked out better for them to hop a little bit because they didn't feel like they weighed as much. So they got farther and could move faster by just hopping along on the moon. Now let's take a look at the phases of the moon. Some of the older students that are in the lesson today may have already seen the phases of the moon. And if you haven't, maybe you can learn some new definitions, some new words today. If you go outside and look at the moon and you watch it night after night throughout a month, you might notice that the moon looks slightly different every night. The moon appears to go through phases based on what part of the moon is lit up and how you are looking at the moon, kind of basically where the moon is in relation to the sun and the earth in all of outer space. Now, we're not going to get into the details of exactly how the moon phases happen today, but I do want to make sure that you know the names of the different moon phases. We'll start with new moon. That's the one in the upper left corner. New moon happens when the moon is in between the earth and the sun, and the side of the moon that we see is not lit up by the sun. So technically during new moon, we actually don't see a moon. That's why it's kind of dark in this picture. After a little time goes by, you might see a little bit of the moon start to light up, the right-hand side. To me, it kind of looks like a skinny banana, but it's technically called a crescent moon. Maybe if you've ever had a crescent roll, you can cook crescent rolls at home. They kind of have that curved shape to them. So we have new moon first, and then a crescent moon when just a little bit of the moon is lit up. Next, we have quarter moons. So it looks like half of the moon is lit up, in this case, the right half of the moon. But in reality, you're only seeing 1/4 of the moon lit up. We don't see the back side of the moon. We only see the front side of the moon, so we're seeing 1/4. That one is called first quarter. And then there's one more word to learn. This word is gibbous. Gibbous is on the right-hand side here. And a gibbous moon occurs when most of the moon is lit up, but not quite all of it. So you can see the right-hand side of the moon is lit up and more than half of it is lit up by the sun, but not quite the whole thing. There's still a little part of it that's dark. So we have new moon, crescent moon, first quarter moon, and then gibbous moon. If we go down to the bottom, we now have full moon. Eventually, the whole side of the moon we can see gets illuminated, it gets lit up by the sun, and we can see the full moon lit up. And then the phases repeat, they kind of go in reverse. Now we have a gibbous moon again. In this case, the left-hand side is lit up. Then we have last quarter, or sometimes people will call it third quarter, when the left-hand side of the moon is lit up. And then finally a crescent moon again, when the left-hand side of the moon looks like a skinny banana. Now, I've actually blocked out a word that goes on top of crescent and gibbous on the top, and another word that goes on top of crescent and gibbous on the bottom. Astronomers have a special word that they use when we see a crescent moon or a gibbous moon and we're approaching full moon. Does anybody happen to know what that word is? It starts with a W, and if you think you know it, go ahead and put it in the chat box. There should be a word before crescent and a word before gibbous that means we're approaching a full moon here. Some of the older students might have already learned this, but go ahead and pop it in the chat box if you think you know it. Excellent, I see some guesses, and we also, have a new class joining. Oh, nice, students from Vietnam, that's awesome, and you can see the moon right now, wonderful, that's wonderful. All right, so we have some guesses on the words that go in front. I see waning and waxing, the waning moon, yep, you guys have the right words there, perfect. So now we just have to figure out which word goes in front, because there's a word that goes in front here. Oh, let me get back to it here. There we go. Oh, we gave away the answer already, that's okay. So in the top one here, we had to figure out which one goes in front. Waxing goes in front of the words when we are approaching a full moon. And then on the bottom, we need that word in front of gibbous and crescent again, but we call it waning. So when the moon is getting brighter, it's getting brighter and brighter night after night, We say that the moon is going to be a waxing crescent, then first quarter, then waxing gibbous. And then when it starts to get less and less bright, we're seeing less of the moon lit up, we have a waning moon. So after a full moon, we have waning gibbous and then waning crescent. Now, students often find it a little tricky to remember which is which. Like, is it the one where the moon is lit up on the right-hand side that means I'm getting close to full moon? Or is it the one where I'm lit up on the left-hand side that means I'm getting close to full moon? That's a tricky thing to remember, but I have a fun saying that you can remember that'll hopefully help. So what I often teach my students is the phrase, light on the right, getting bright. So if you guys want to all say it with me in your class together, are you ready? Light on the right, getting bright. So if you take a look at our pictures behind the words, if the moon is lit up on the right-hand side, the moon is getting brighter. We're approaching a full moon. And I don't have a fun phrase for when the moon is lit up on the left and approaching new moon. Maybe that can be homework for you guys. Come up with a fun phrase or words that help you remember that. But if you at least remember the top one, then you just have to know that if it's lit up on the left, it doesn't fit into the saying, and we must be approaching a new moon. So those are some fun ways to remember the phases of the moon, and I encourage you to go outside and take a look at the moon whenever you have a chance. So one special thing to note about the moon and the phases is that the moon rises and sets at different times of day and night, depending on the phase. So unfortunately, you can't just go out every single night and always expect to see the moon, because sometimes the moon is up during the day and sometimes the moon is up at night. So depending on the phase, you need to know when you should go outside to see it. So the little chart I have down here is a good reminder. If we are experiencing new moon, the moon is going to rise with the sun. So the moon will rise at sunrise and the moon will set at sunset. And during new moon, we usually can't see the moon in the sky. About a week later, we will have first quarter moon. That means that you'll be able to see the moon come up in the sky at noontime. So in the middle of the day, the moon will start to rise in the east. And then it's going to set at midnight. So you'll be able to see the moon in the west right after the sun goes down. During full moon, the moon and the sun are on opposite sides of the sky. So the moon will rise when the sun sets and set when the sun rises. So you'll be able to see a full moon all night long. And the last one, third quarter, that one rises in the middle of the night and sets in the middle of the day. So if you want to see a third quarter moon, the best time to look is in the morning. And this is true no matter where you are, no matter what state or what part of the planet you're on. It's whatever your local time is, that's approximately when you will be able to see the different phases of the moon. So speaking of the moon, let's take a look at the moon, and I want to see what our full moon looks like. That is what our full moon looks like, and that is the side of the moon that we get to see. We only ever get to see one side of the moon. The way the moon orbits and the way the moon rotates, spins around on its axis, makes it so that we only ever see this side of the moon. Now, if you look at the moon closely, I can see a couple of interesting features. I can see what looks like at least one big hole and lots of little holes around the moon. If you know what those holes are called, go ahead and put it in the chat box. There's a name for those big circles, those big holes on the moon. What do we call them? Very good. Yeah, you guys got it. You're super smart. Those are called craters. The moon has a ton of craters on it. Lots and lots of craters, thousands of craters. Now, I also see dark areas on the moon too. Let's see. Oh, I want to go back one real quick. Here we go. There's these dark areas. Now, some of them are really big craters but there's a special name for the dark areas on the moon too. Do you know what the dark areas are called? Can you put that in the chat box too? There's a name for that as well. What do we call those darker gray parts of the moon? I will get to your why do we have craters question in just a moment. Crystal says man on the moon. Yep, we're going to talk about those features that you see in just a moment. Let's see, Caleb and Kayana say the Sea of Tranquility. Very good. I see shadows and craters. Yeah, seas, very good. So there is a scientific term for this. Those dark areas on the moon, we call them mare, M-A-R-E, or seas, right? Now that term comes from a long time ago, before we knew what the moon was actually made of. And astronomers thought that maybe those dark areas were actually seas or oceans on the moon. We know today that that's not the case. We'll talk about what they are in just a moment, but they kind of look from far away like they might be darker oceans. So we call them seas, and you guys are right. The Sea of Tranquility is one of those features. So I'll come back to the seas in a moment, but I want to point out the fact that you can see things in the moon, and somebody already mentioned the man on the moon, which is perfect. So you can stretch your imagination to see all sorts of things on the moon. There's a couple of common ones. So for example, you might see here the man on the moon. Maybe you imagine two eyeballs here, a funny looking nose, and a little bit of a sideways mouth here. There's a whole bunch of different ways to see the man on the moon, but that's just one example. Me personally, I often see an upside down bunny rabbit. That's what I like to look for. Look on the right-hand side, and maybe you can see what I see, an upside down bunny rabbit. So there's the body, the head, two tall floppy ears, and a fluffy tail. So that's kind of what I see when I look at the moon. And if you're curious where the people landed on the moon, at least on Apollo 11, the first people that landed on the moon, they landed right here, right at the base of the ear and the top of the head of the imaginary bunny rabbit on the moon. So let's talk for a moment about those craters. Some of you already asked about where the craters from, where the craters come from. So I've zoomed in on the big crater on the bottom. That is the Tycho crater, and it's 50 miles wide from end to end. So this picture was taken with a satellite that orbits around the moon, and it's really a really large crater. From end to end, it'd be 50 miles. So if you had a normal car, if you could drive a normal car on the moon, it would take you about an hour to drive from one side of the moon's crater to the other. So it's really, really big. It kind of looks small in the pictures, but it actually is really quite large. And there's a big clump of material in the middle and a big hole here. Now, how did this hole form? We got to figure that one out next. Let's take a look at one other crater before we get to that. Oh, nope, I lied. I do have this one here. So how do we form them? So here we have our little cartoon. Now, of course, there aren't actually faces on rocks flying through outer space, but it kind of gives you the idea of what's going on here. So in outer space, our moon gets hit by rocks all the time. And when a rock or an asteroid hits the moon, it exerts a lot of energy on the moon, and it crashes into it and makes a big hole. So you can see when the rock dives onto the moon, it makes a big hole, it tosses the material sideways, and we end up with a big crater. So that is how the Tycho crater formed, and that is how all of the craters form on the surface of the moon. So we can take a look at one of the other parts of the moon where there are a lot of craters. You could sit here for a while and count a couple hundred craters in this picture. notice that there's a big crater in the background and lots of little craters, little holes in the foreground. That big crater in the background formed first, and then the moon was hit by lots of smaller rocks that made the little craters. The bigger the crater, the bigger the rock that hit the moon to form it. That's how craters work. Now I want to go back to those seas, those mare, real quick. Those dark areas on the moon, they all have special names. Somebody mentioned the Sea of Tranquility already. That's basically the head of the bunny over here. And there's a bunch of others. There's, let's see, the Sea of Crisis, Sea of Serenity, Sea of Showers, Ocean of Storms, all sorts of different names. And what they really are, those dark areas on the moon, are places where lava from old volcanoes flowed out and filled in the craters. So if we look at my upside down bunny rabbit, you can see that the seas are kind of circular. Originally, they were really big craters, and then when volcanoes erupted on the moon, all of the molten rock filled in the craters and made them nice and smooth and kind of dark in color. Nowadays, we don't have any volcanoes erupting on the moon, but long ago, and we're talking millions to maybe even billions of years ago, there were active volcanoes on the moon, and lava was filling in all of the craters, making a couple of those seas. I want to show you both sides of the moon. So far, we've only been looking at the side of the moon that we get to see. We call it the near side of the moon. That's the one pictured on the left. On the right-hand side, you can see the far side of the moon. And the far side of the moon looks a little bit different. The near side has those mare, those seas, and the far side of the moon doesn't really have those big dark patches, at least not as many. And it looks like there's a lot more craters. If you look at the right-hand side, there's a lot more craters on that side of the moon than there is on the side that we see. Now, a lot of people naturally think that the back side of the moon has more craters because the moon is protecting the Earth, right? If it's got its back to Earth, then any rocks that come by are going to hit the back side of the moon. Now, that kind of makes intuitive sense, and I can understand why people think that, but that's actually not why the back side of the moon has more craters. In fact, the side that we see and the back side, the side that we don't see, have been hit by an equal number of rocks. So there should be an equal number of craters. But what's actually going on is the side of the moon that we see had many more volcanoes. The crust of the moon was thinner, the top layer of the moon, and because it was thinner, more volcanoes could form and more lava could come out and fill in the craters. So back long ago, the back side and the front side of the moon looked exactly the same, and then after the volcanoes let their lava out, it flowed and filled in all the craters, kind of smoothing them over. So it wasn't that the backside got hit more frequently or more often, it's just that the backside of the moon didn't have as many volcanoes to spew lava and fill in the craters. So we still see every single one of the craters that ever formed on the backside of the moon. So I want to finish up here with two things. I want to talk just a little bit about the different names of the full moons, and then I'll show you the best time to go outside and see the moon. Here we have a list of some common names of full moons. Every month, a full moon has a special name. These ones come from, I believe, mostly Native American culture. There might be a couple of other cultures mixed in, but just like constellations, where the Greeks and the Romans, the Native Americans, the Chinese astronomers, they all had different names for pictures in the sky. Different cultures have different names for moons as well. And these are the ones you're going to see most commonly. From top left to bottom right, this is January's full moon, and this is December's full moon. January is the full wolf moon because the wolves are often howling at the moon in January. February is the full snow moon, so for those of you that live a little bit more north, you're going to experience snow in February, so that's why it's the full snow moon. March is the full worm moon because usually in March the ground starts to thaw, it gets filled with water, and that's when the worms start to crawl out from the mud. The full pink moon in April, that has to do with some pink flowers that would often bloom before any other flowers in April, so that's where that nickname came from. May is the full flower moon. You might have heard the term April showers bring May flowers, so by May usually a lot of the flowers are blooming. June would be the strawberry moon because in a lot of places the strawberries are ripe and ready to be picked by June. July is the full buck moon, so the deer usually have their antlers by, where are we, May, June, July. By the middle of July, the deer have their full antlers. August is the full sturgeon moon. A sturgeon is a type of fish, so the sturgeon were very prevalent in the middle of August. September, the full corn moon, that's when a lot of people, again, more in the northern part of the country, they will harvest the corn at that time. We've got October. October is the full hunter moon, so hunting season for certain creatures begins in October. November, the full beaver moon, when our beavers are starting to build their dams to get ready for the winter. And then December, the full cold moon, because those of us in the northern hemisphere get pretty chilly by the time December rolls around. So these are just one example of a set of full moon names by one culture, and you could come up with a story for these, or you could make up your own full moon names if you want to. Think about maybe what's happening during those months to kind of give a clever name to the full moon. All right, so I just want to mention the best time to view the moon, and then I will start to take questions here. So the best time to view the moon is actually not when the moon is full. The best time to view the moon is when it's about quarter or maybe gibbous phase. And that's because you've got part of the moon lit up, like you see in this picture, and part of the moon is not lit up. And there are shadows cast by the edges of the craters from the sunlight right here at the edge. And you can see the craters and the features of the moon a lot better right here at that line where it goes from light to dark. We call that the terminator on the moon. So it just makes the features more prominent. They're easier to see. It's easier to tell how big or small the craters are. And if you have a telescope, this is an excellent time to point a small telescope at the moon, look right at the edge of the moon, and you can really see the craters in great detail. Now, of course, it's fun to look at the moon at any time, but the best time to look at the moon is definitely when about half of the moon is lit up. So I will leave up this slide as I take questions here. The reason I chose to do this presentation here is because International Observe the Moon Night is coming up. It's a worldwide celebration. This year it's happening on October 5th. And if you have a science center nearby, they're probably going to be doing activities for this special event. And it's just a wonderful event that encourages everybody to go outside and look up. The moon will be, I believe, in about first quarter phase, so it's an excellent time to go outside and see the moon. And if you have the ability to use a telescope or go to your science center and use one of their telescopes, you should definitely go. It'll be a really, really great experience. So I'm going to pull up the chat box in the Q&A. If you have questions, please put them there. My email is also at the bottom of this slide, so if I don't get to your question, you can always email me the question later, and I'd be happy to answer it for the class. All right, so let me go through here, pull up both boxes. All right, so Andre's class asks, during the Apollo 11 mission, lasers were placed on the surface. Are those lasers still used today? So yes, they are, and it wasn't actually the lasers that were put on the moon, it was the mirrors that reflect the lasers. So here on Earth, we have a big telescope that has lasers on it, and we shine those lasers at the moon, and those lasers bounce off the mirrors that the Apollo astronauts put down, and we use that to figure out how far away the moon is. We are so good with our technology today that we can measure how far away the moon is down to 1/2 of an inch. That is the accuracy that we can get with that laser system. We can measure how precisely far away the moon is down to ½ an inch distance. Excellent. So we had a couple of questions coming through about gravity. So if you're not familiar with gravity, gravity is the thing that holds your feet to planet Earth. So we don't float away into outer space because gravity exists on our planet and it holds our feet down to the surface. So on the moon is smaller, there's less gravity, there's less strength holding us down onto the surface, so it's easier to move around. Let's see, there's lots of good questions here. When did the first crater hit the moon? We don't actually know because it was long before human beings existed, but probably 4.5 billion years ago, a long, long time ago. That's about when our moon formed, and right away it started to get hit by lots of rocks in outer space. Let's see here. How was the moon formed? Where did it come from? Yeah, and then Andre put in some answers in the chat box. Yeah, so the main theory right now is that the Earth had formed and a large object about the size of Mars, current day Mars, hit the Earth and knocked off a whole bunch of material. And a lot of that rock and dust and debris collected back, stuck back together because of gravity, and that is what formed our moon. So you can imagine a really big rock knocking 1/4 of the Earth off, kicking all that material into outer space, and then that material sticking back together and forming our moon, and then just naturally starting to orbit and spin around the Earth. So that is the current theory, although there are a couple of other theories out there as well. Sarah's group asks, how do you measure the moon with lasers? So what you do is you take a telescope with a laser on the bottom, and you shoot the laser at the moon. It hits the mirror and it bounces back. And what you actually do is you measure the time it takes for you to send the laser and for it to hit the moon and come back. It should be about 2 seconds. That's it. That's all it takes, is about 2 seconds for the laser light to come back. If you measure that number very precisely down to small fractions of a second, you can do a little bit of advanced math to figure out how far away the moon is based on how long it took a beam of light to get to the moon. So hopefully that answers your question in simple terms. I'm happy if you want to email me later to give you a little more complicated information. But that's basically how we do it. We measure how long it takes the laser to get to the moon. We have a question. What's the orange moon? You might be thinking, well, there's a couple of different things. The orange moon, when the moon actually looks orange in the sky, sometimes we call it a harvest moon. That is when the full moon is low in the sky, so right after it comes up, and the light that is bouncing off of the moon passes through a whole lot of Earth's atmosphere. And since Earth's atmosphere scatters away blue light, that's why the sky looks blue every day during the day, the only light that we end up seeing that bounces off the moon is the orange and red colored light. So sometimes the moon looks orange when it's low in the sky just because of the colors of light that make it through the air around planet Earth. Sometimes we'll see the moon as a red moon, or they'll call it a blood moon, and that happens during a lunar eclipse. That's a little bit different, but I think you're thinking more of the harvest moon. Yes, Sarah, to answer your question quick, I'm happy to post the slides, and I believe this presentation is recorded too, so you can always go back and play it again. Let's see, Crystal's group asks, what year did the first man walk on the moon? So the first people to touch down on the moon, that was 1969, long before I and probably most of you were born. So 50 years ago, we just celebrated the 50th anniversary of Apollo 11 this summer. Check my time here. We got a few more minutes. Let's see. Why do some planets have more than one moon? That's a good question, Tyler. So usually, the bigger the planet, the more moon it's going to have. And that goes back to the idea of gravity. big planets like Jupiter have lots of gravity, so it's easy for them to hold on to moons. Now, the reason that Earth and the planets that are close to the sun only have one moon or no moons at all is probably because of the sun. The sun is really big, and Mercury, Venus, and Earth are pretty close to the sun, so the sun's gravity would have captured any rocks that might have eventually made more moons around those planets. But the gravity of the sun was so powerful, it pulled all of those rocks in towards the sun, so they weren't going to end up as moons around the planets. Jupiter has the most moons. I think we're up to 79 moons total now, so a whole lot of moons around Jupiter. Andre, did the Apollo missions land in the Sea of Tranquility? Yes, they landed, right at the bottom of those bunny ears. Excellent, and I do see that we have to wrap up here. There are some questions I didn't get to, so if your class would like to ask that question, again, my email is at the bottom of the slide, so feel free to email it to me and I'm happy to answer your questions. But we do need to wrap up so we can have a new group come in. Thank you all very much. I hope you enjoyed the presentation, and please look out for future lessons by me. I've got a whole bunch planned for this school year. So thank you, everybody, and have a great rest of your day.
Ok các bạn, chú xin lỗi. Các con có thể giơ tay và chú muốn hỏi xem là cái cảm tưởng của mọi người thế nào. Đây có phải là cái hoạt động mà có ích không? Mọi người có học được thêm cái gì về, có hiểu được thêm về mặt trăng hay là không? Chú muốn hỏi, để bây giờ thấy có Phan Anh Vũ giơ tay. Ok, xin chào Phan Anh Vũ. Con. Thế nào?
Có thấy buổi học này rất là hay, bởi vì năm ngoài cháu cũng từng học về mặt trăng, nhưng mà năm nay sau khi học qua buổi học này thì cháu mới biết là có đến tận 30 trái đất thì mới gọi là có một mặt trăng ở giữa, hay là cái
không phải, tức là cái khoảng cách giữa khoảng cách mà từ trái đất đến mặt trăng là lớn bằng
30 lần trái đất,
30 mấy lần cái đường kính của trái đất, tức là khoảng cách thì rất là xa.
Cũng biết được là khoảng cách đo thực sự. Với cả cái hôm mà chú học ở Hà Nội là cháu cũng là người bắt tay với chú.
Hello.
Vâng, chú ạ.
Hello anh Vũ. Ok, cảm ơn rất là nhiều. Chú hy vọng là các bạn cảm ơn con. Cảm ơn, hy vọng là các bạn thích cái này, bởi vì là nếu các bạn thích thì là buổi sau chúng ta sẽ xem những cái video khác. Chú không biết là có phải lần nào chú cũng dịch được tốt hay không, bởi vì có những cái chủ đề ví dụ như là về sinh vật hay là vân vân thì thôi, dịch được đến đâu thì hay đến đấy. Thế nhưng mà có những bạn nào hôm nay mà nghe bằng tiếng Anh và bạn nào nghe bằng tiếng Việt, chú muốn tò mò muốn hỏi thử xem là có bạn nào mà nghe bằng tiếng Việt, làm ơn giơ tay. Chú muốn hỏi một chút phản hồi về cái dịch. Mọi người nghe, mọi người có cảm thấy ổn không? Chắc là thể nào cũng có người bảo là ôi ổn lắm ạ, hay là 100% mọi người đều khen chú hả? Ok, có bạn nào giơ tay? Trần Hạnh Nhiên, xin chào ạ. Alo ạ. Ok, có bạn nào có câu hỏi gì hay là có gì cần nhắn gửi chú không? Thế xong Xin lỗi mọi người, chú xin lỗi. Ban nãy chú để cái filter, thế mà bây giờ mới để ý thấy là có rất nhiều bạn giơ tay. Ban nãy thì không thấy. Ok, Phạm Khôi Nguyên. Hello Phạm Khôi Nguyên. Hello Phạm Khôi Nguyên ạ. Ok. Tạo huy hoàng nào. Tạo huy hoàng.
Con chào bác Gấu.
Ok, hello.
Con có một câu hỏi là con muốn có một câu hỏi là con hôm nay lúc vào giờ học ý thì con đã chuẩn bị một cái kiểu như là ca hút về mặt trăng ý, con chỉ mới show thôi, có được
Ok,
không ạ?
được. Có dài lắm không?
10 question ạ.
10 question, ok. Thế thì Hoàng để cho bác Gấu Bách Hoàng là co-host để share hả?
Vâng ạ.
Ok.
Để con.
Ok.
Được chưa ạ?
Được rồi. Hoàng thử share xem nào. Ok. Mọi người nhìn thấy cái ca hút Hoàng có nhiều bạn có thể không phải là MVA, Hoàng chia sẻ với các bạn xem là làm thế nào để các bạn làm thế nào các bạn có thể join được. Ok, mọi người nếu mà quen thuộc với Kahoot thì có thể đến kahoot.it và đánh cái pin là 9193911 9193911.
Bác Gấu có vào không ạ?
Để bác xem.
Bác vào thì ghi tên là Chú Gấu cho con nhá, để con còn biết.
Sao bác lại ghi là chú à? Bác không...
Bác Gấu, hoặc là ghi là anh Phạm cũng được. Nghĩa là
Kahoot.
có dấu hiệu để biết là có bác Gấu ở trong.
Kahoot. Để... Ok, cái 9193911 hả? 9193911. Ok, enter. Nickname. Thần gấu. Ok, mọi người thử vào cái trang kahoot.it, sau đánh cái code mà Hoàng đưa vào là 9193911.
Từ từ. Bác Gấu vào chưa ạ?
Rồi, thần gấu.
Ok.
Có 92 bạn rồi. Lạy thần gấu. Dám trêu mình.
Thôi con bắt đầu nhá.
Ok.
Bốn mươi bốn bạn. Bảo Thiên Vũ đang đứng thứ nhất nhá.
Ôi giời ơi, nhiều người ăn gian thế.
Gian gì hả?
Có nhiều người ăn gian.
Ăn gian kiểu gì hả?
Bác Gấu đang thắng, cuối cùng tự nhiên lại thua thì là thế nào?
Tôi không biết nữa, chắc bác Gấu câu đấy có ấn có đúng không ạ?
Nói chắc là có một câu hình như bị sai. Câu tức là cái đề có một câu bị sai. Cái câu mà waning với waxing ấy.
À,
Cái wane khi mà nó đang chết dần đi thì nó là waning. Thì cái mà mặt nó ở bên tay phải thì nó đang phải là wane chứ không phải là đang wax. Cái đấy là đề bài bị sai.
con
Tức
cũng
là
chả biết nữa.
light, oh no, light on the right, getting bright. Thế bác Gấu sai rồi. Tức là khi mà bên ánh sáng mà ở bên phải thì là mặt trăng đang ấy lên. Thôi, giỏi quá. Cupcake giỏi quá. Bảo Vũ Tê Bảo bị bạn cupcake ở đâu nhảy lên đề luôn. Ok, cảm ơn các con rất nhiều. Thế bây giờ
Còn một câu cuối mà hình như thế.
còn một câu nữa à?
Vâng ạ.
Ok, ok. Wow. Thần gấu. Giỏi thế. Các bạn giỏi quá. Wow. Cupcake kia là ai?
Bác cứ hỏi. Nếu bác Gấu muốn biết cupcake kia là ai ấy, thì cứ cái gì nhỉ? Hỏi ở trên chat đi ạ.
Thế à, nhưng mà bác đóng cái chat lại rồi. Có bạn cupcake kia, em để bác Gấu mở cái chat ra cho các bạn nhé.
Từ từ, con muốn hướng dẫn các bạn làm một cái này để tìm cao hút nó dễ hơn. Con có một bí quyết lâu đời. Đây, con đâu rồi ta?
Cupcake kia giỏi thế. Vượt lên Bảo. Oh. lạy thần gấu đâu rồi?
Đây này, để con hướng dẫn cách tìm nhá. Đây, đầu tiên là Valkyrie at Kahoot này. Ui, con nhầm mất rồi. Con nhầm là đây. Rồi sau đó bác Gấu thử vào cái create Kahoot này đi.
Create
Rồi
à?
sâu cho bộ. Vâng ạ, kiểu như là mẫu cho con ấy, bởi vì con đã đăng cái này trước rồi. Bác Gấu show ra đi.
Đây, hold on. Share này.
Không, vào cái create Kahoot đi ạ.
Đây, đang chờ bác Gấu đang vào. Mọi người nhìn thấy đúng không?
Đây, rồi ấn vào sign up. Không, sign up ạ.
Sign up à?
Vâng ạ. As a teacher. Rồi ấn vào sign up with Google. Rồi đấy. Rồi bác Gấu cứ làm tiếp thôi à? Nhưng mà của cháu thì cái này là không làm, không cần. Rồi ạ. Rồi join Kahoot ạ.
Ok.
Sao nó khác thế nhở? Của con bình thường là nó phải như khác cơ mà. Để
Có
con
thể
đăng
là
xuất
tại vì là as a teacher create hay à?
Vâng ạ. bình thường là nó phải ra cái
có thể là với học
mà.
với
Không, con có ấn sao lại để discover chứ?
Thế à, nó có một cái cách khác à? Thôi rồi, Hoàng ơi.
Đây, hình như thế.
Đúng không?
Đây để con hướng dẫn lại cho bác Gấu tắt lấy cái phần của bác đi để con làm lại cho. Con quên mất là có phần.
Unshare nhé.
Vâng ạ.
Ok. Để Hoàng share.
Đây, thế này nhá. Rồi bây giờ con sẽ ấn vào sách up này. Rồi, as a teacher. Bình thường là nó ra thế này luôn. Đây, nó ra thế này luôn, discover này luôn. Giờ muốn search cái gì cũng được, ví dụ như là
Moon face.
đây, moon face, moon. Đấy của con lúc nãy là cái này.
Hay nhỉ?
Vâng. Rồi sau khi bây giờ nhá, rồi sau khi ấn vào này có rồi cái phần play này là để chơi, là mình show cái ca hút này ra. Còn cái create này là cái dùng để tạo ca hút của mình.
Ok, đúng rồi, bác Gấu hiểu rồi. Ok, các bạn yêu quý, chúng ta sẽ đến chiều tối nay thì MVA sẽ học bình thường, nhưng mà đến lúc 9:15 thì cô Lisa Bowden sẽ dạy cho các bạn. Cô sẽ đi ra tận sân khúc côn cầu để cô quay, để cô làm cho các bạn xem cách chơi khúc côn cầu. Ok, chào các bạn nhé. Cảm ơn các con đã dành thời gian. Xong đấy rồi chúng ta sẽ gặp nhau sớm nhá. Ngày nào cũng sẽ gặp, trong tuần này sáng nào cũng sẽ có cái gì đó để cho các bạn. Ok nhá. Bye bye cả nhà. Cảm ơn Hoàng.